Today's tutorial we are going to discuss about the derivative of implicit function. So first is that what is implicit function. So before explaining about the implicit function, so let's recall about the explicit function. Okay, we have explicit function and implicit function. First, let's have the explicit functions, which is already known to us is represented by y is equal fx, and for example these are y equal x square, y is equal sin x, y is equal tan x, y is equal e to the power x, y is equal ln x. Now if we see here that y is dependent and x is independent, we have exactly that dependent variable is directly depend on the independent variable. So when you put the value of x, you will see you have all the value of y immediately. So this function is known as the explicit function, means dependent variable explicitly written in the terms of the independent variable. But in the case of the implicit function, we have the form of the function is like this, say f of xy is equal 0, means the independent variable and dependent variable are connected with each other. It's not in the separable form that you separate or explain the dependent variable in the form of the independent variable directly. So this type of the form is known as the implicit form. For example, say y is equal x plus x y square. So here if you see that if you put the value of x, you will not get directly the value of y, you will get a new expression of y. So this type of the form is known as the implicit function. So let's more example, y is equal sine xy, y is equal e to the power x plus y plus tan x square, y is equal say ln x square plus y square. So these are all are implicit function. So now next is that how to find the derivative of implicit function. Means if you have the function f of xy is equal 0, then how to find dy dx. So this is step 1. Apply dy dx on both sides. d dx of f of xy is equal 0. Step 2. If a term have only x variable, say gx, then apply all rules and find d dx of gx. If the term have only y variable, say hy, then apply chain rule ddx of hy is equal ddy hy dy dx, and for this part rule of the derivatives. So, and if you have the mixed part, when some function is mixed up with x and y, then you have to apply the rules like to separate them, like addition, subtraction, multiplication, and apply these two category as in described in the step 2, and you will get the derivative. Let's have take one simple example here. So as we say that step 1, apply d dx on both sides. D dx of y square is equal d dx of x plus d dx of 3y. So now in this case you will see that this is the variable with respect to y only. So we will stop this step 2. So you will get it here 2y y square, derivative of y square is 2y dy dx. This is equal derivative of x is 1 plus 3 dy dx. Now collect dy dx. So 2y minus 3 dy dx is equal 1. So this implies dy dx is equal 1 over 2y minus 3. Now we have our first example here. Find y dash x from y square is equal x plus xy. This is, so it's a function of y square, so we'll apply the chain rule. So you will get it here 2y dy dx is equal d dx of x plus d dx of x y. Now this part you have a product of two terms x and y. So here we will first apply the product rule and then we will solve the derivatives. It will gives us 2y dy dx as it is. This will be 1 plus apply the product rule here x dy dx plus y dx of x, which will be 1. So now collect dy dx. So you will get it here 2y, and this is minus x dy dx is equal 1 plus y. So this implies dy dx is equal 1 plus y over 2y minus x. This is the answer. Our next example is y equals sin x plus tan x plus y, and we have to find dy dx. Apply d dx on both sides. We will have dy dx is equal d dx sin x plus d dx tan x plus y. D dx sin x, which will be cosine x, plus here we will apply the chain rule. So chain rule on tan x first, second square x plus y, and then derivative of x plus y. So this is equal cosine x plus secant square x plus y, and then derivative is 1 plus dy dx. Then collect the dy dx together. So you have here 1, and this is minus secant square x plus y is equal cosine x plus secant square x plus y. So this will gives you dy dx is equal cosine x plus secant square x plus y over 1 minus secant square x y. Find y dash from xy square equal to the power x square. So solution here, we'll apply d dx on both sides. Apply the product rule here, d dx y square plus y square d dx of x is equal. Here we will apply the chain rule on e to the power x square. So e to the power x square as it is, and then derivative of x square. So this implies here again apply on the chain rule x, then 2y dy dx plus y square is equal e to the power x square to x. So now we'll simplify 2xy dy dx is equal 2x e to the power x square minus y square. This implies dy dx is equal 2x e to the power x square minus y over 2xy, which we can write it as e to the power x square over y minus 1 over 2x. Next example is find y dash x from cosine y square equal x to the power 4 plus 5y square. So apply d dx on both sides. So here apply the chain rule on cosine first. So cosine derivative will be minus sine y square and then d dx of y square, which is equal 4 x to the power 3 plus 5 dy dx. Now again we'll apply the chain rule on y square. So you will get it here sine y square 2y and dy dx is equal 4x to the power 3 plus 5 dy dx. Now collect the dy dx. So this implies dy dx is equal 4x to the power 3 over 2y sine y square plus 5. Next problem is find y dash 1 from y to the power 4 is equal x minus xy plus 3y square. So first find y dash and then we'll see about the y dash 1. So apply d dx on both sides. So apply the chain rule here. 4 y to the power 3 dy dx, this is equal 1 minus, here apply the product rule, x dy dx plus y plus 6x. Collect dy dx. dy dx is equal 1 minus y plus 6x over 4y to the power 3 minus x. So this implies dy dx when x is equal 1 is 1 minus y plus 6 4y to the power 3 minus 1, which is equal 7 minus y over 4y to the power 3 minus 1. Now here we look that we don't know the value of y when x is equal 1. If it is given, then we can calculate it. Otherwise, we may keep the answer is with respect to y.